Welcome to Pre-Calculus 7.3 Part 2 of our lecture on parabolas, where we're going to talk about a few more skills that we need to know. Okay, so this next skill we're going to learn is we start out with general conics form of our equation, and we're going to learn how to convert it to your standard form for a upwards or downwards facing parabola, or to your standard form for a sideways facing parabola. Now, I'm not going to go ahead and read through these steps now, but you can go ahead and write those down in your notes, because generally what happens is they're not going to sink in until we actually do some of this work ourselves. So let's just jump into the problems and make a note that these are the steps we're going to be following. If that helps you in any way, to go back to refer to the steps written down in words. All right, so let's look at this example. This says, given the equation in general conics form, that's this, find the vertex, focus, and directrix, and sketch the graph of the parabola. So it's not very useful in this form, so that is why we want to change it into this form here, which we practiced doing in the first half of this lecture. All right, we practice working with, I should say, in the first half of the lecture. All right, so standard conics form, if it is a parabola, will have one squared term. So it will either have a x squared term or a y squared term, but not both. All right, if it has both, then it's not a parabola. All right, so this has a y squared term, so it is a parabola. It's a y squared parabola. We know a y squared parabola is of the form, this form here, if it's in standard form for a parabola. So a y squared parabola is a sideways parabola. All right, so we're going to take this and get it in this form now. So step one of our steps here says, group the variable which is squared onto one side of the equation, and then basically everything else on the other side. So let's do that. All right, so the squared term is your 2y squared, and the other y term that would have to stay with it is the 4y. So I've kept all the y's on the left-hand side. Everything else is going to get moved to the other side. All right, that's step one. All right, then step two on this slide here says complete the square if necessary and divide by the coefficient of the perfect square that we create. So we're going to do that now. So I do have a coefficient here. We have to be careful of that. This is not just a 1, it's a 2. So if you have a coefficient there, I want to pull it outside of the parentheses. Right? Be very careful there. So now I want to make sure that everything on the left is treated such that that 2 is factored out of it. So this next term is going to be a 2y. All right, so I basically divided that 4 by my coefficient 2. And you want to really be careful here to check yourself by distributing. Make sure you get back to this. 2 times y squared, yes. 2 times 2y, yes. Okay, so now we say plus blank for completing the square equals negative x plus 8. All right, so now I'm going to complete the square. Let's put our balancing blank in, don't forget that. All right, so I take my middle term 2, and I divide by 2, and I square it. So 2 divided by 2 is 1. 1 squared is 1. Now at this point, you have to be careful that you realize that you do have 2 times 1 on the left-hand side because it's inside the parentheses. 2 times 1. So I've added a 2, which means I need to add a 2 on this side. And this is a mess-up place if you're not careful. All right, so I've added a 2. Now, let's get that perfect square trinomial in factored form. So that's y plus 1 squared, the same way we did with the circle, where y goes here, plus goes here, and the square root of 1 would go here. All right, then on the left-hand side, I've got equals negative x plus 10. All right, now I'm at this stage of the game where I want to divide by the coefficient of the perfect square. So I have a coefficient here of 2, so I want to divide by 2. So we want to write parentheses around here and put the divide by 2 out front like that. All right, because we want our equation to look like this, where you've got whatever number that sits out front here kept out front there and not incorporated in with any of this stuff here. All right, so let's finish getting this in the correct form. So now this is gone. So on the left I've got y plus 1 squared, and I've got the 1/2 out front, but the problem is I've got a negative in front of the x like that, and I don't want a negative in front of the x. I want a positive in front of the x. So I'm going to factor out that negative out of both of these terms and put it out in front here. So that will be the last thing I need to do. So I'm going to factor out my negative, which is going to reverse the signs on the 2 terms inside there. And you can check yourself. 1/2 times negative x will still give you this same thing, negative 1/2 times x. 1/2 times 10 will still give you the same thing, negative 1/2 times negative 10. So these 2 statements are equivalent. All right, so now I've got it looking like I want. This here now looks like this here. We're done. So we've got the equation in the right form, and that's just half of the work. Now we got to figure out the information it asks for. So I'm going to erase some of this stuff and just keep my equation so I have enough room. Okay, this is the equation that we arrived at. So now, since it says a y squared parabola and I have a negative here, that means it's sideways, but it's pointing in the negative x direction. So let me just make a note of that. It's going to be like this, and my focus is always inside the dish. So the first thing we need is our vertex. So our vertex is HK. All right, so remember this is H, opposite sign, and this is K, opposite sign. H goes with X, K goes with Y. So I've got 10, opposite sign, negative 1, opposite sign. So now I can plot my vertex on my graph. So vertex is 10, negative, oops, let's go down 1. Okay, vertex 10, negative 1. All right, so now we're going to find the focus. So remember that this 4p resides in this spot right here. So in our equation, 1/2 is equal to 4p. So 1/2 is equal to 4p, or 4p is equal to 1/2. So I can do cross multiplying. 8p is equal to 1 times 1. P is equal to 1/8. All right, so we have a fraction for p. So this means that I'm going to take 1/8 and I'm going to go to the left from the coordinate here, which is 10. So that's basically 10 minus 1/8. So that's, if I multiply by 8 over 8, 80/8 minus 1/8 is equal to 79/8. All right, so that is my x coordinate of my focus. So let's write my focus up here. My focus, my x coordinate is 79/8, and I'll still be on that same negative 1 y line there. So if I try to draw that dot in there, it's going to be really hard to see that small amount, but we'll just exaggerate it a little bit. So this is my focus, which is to the left of my vertex. All right, like we said here, it's always inside the dish, so my dish is going to go this way. All right, so that's my focus. Now we can do the directrix. So I'm going to keep this here because I can use this same setup to go the other way. So if I went to the left, I subtracted 1/8 to get 79/8. And if I go to the right to get my directrix, I'm going to add 1/8 to go to the right. Going to the right means add. So I'll get 81/8. All right, and that's going to be where I cut through with my directrix line. So let's sketch that in. All right, so I exaggerated that 1/8 distance here because it would be really hard to see that on this graph the way the squares are drawn. So let's write that out. My directrix then, so we can erase some of this now. All right, so the last thing we have to do is make a sketch of this graph. And to do that, to get the width on here correctly, we're going to find the length of the focal diameter. So my focal diameter in this case, the length of it is 1/2. So this is going to be a skinny parabola. So half of 1/2 is 1/4. Half of 1/2 is 1/4. So in line with my focus is going to be my focal diameter. So I'm going to go 1/4 up. Let's just see if I can get it in there. 1/4 up this way. And let's erase that F so we have enough room. And 1/4 down this way. All right, so that should be enough information then to get my parabola drawn in there accurately. Let's just make this a little bigger. All right, so I'm going to go just like that, and that is going to be my rather narrow parabola. So we've got it all done here. Answers the question. All right, let's try it again. Given the equation in general conics form, that's this. Find the vertex, focus, and directrix and sketch the graph. Right, this time I've got an x squared parabola. So your standard form for an x squared parabola is this. So this is our goal. So our steps are we want to keep your squared terms on the left. So that would be my x squared. And then also the other x term on the left. Everything else is going to move over to the right-hand side. I do not have a coefficient this time to factor out, so I can go ahead and set it up with my blanks. So I've got blank to complete the square, and I have another blank over here to balance. So to complete the square, I take my 10 divided by 2, which is 5, and square it. So that gives me 25, which I'm going to put on both sides. All right, so now if I write my perfect square trinomial, which I created in factored form, I'll have x minus 5. All right, and then on the other side, I'll have negative 12y plus 24. Negative 1 plus 25 is 24. All right, so let's get the left-hand side fixed up a little. I need to factor out the GCF on the, I mean the right-hand side. I need to factor out the GCF. So we've got a negative here, a negative 12. So if I factor out a negative 12 out of both terms, I'll have y, let's see, minus 2. And then you want to check that. So that would be negative 12 times y, yes. Negative 12 times negative 2, yes. Now here's a word of caution. Don't be afraid to just write something down, because at least you've got something in your mind as to how this factored form would look going from here. Then you just check it and refine it if necessary when you do your distributing to make sure you've got your signs correct. So make sure you check that before you say, yes, this is definitely what it is. All right, so you can see I've got y minus k. I've got my 4p, and then I've got my x minus h squared. All right, now let's see what else we need to do. All right, so we need our vertex. So our vertex we can get from hk. So our vertex is opposite sign 5, opposite sign 2. So 5, 2. So this is our vertex right here. All right, so this is an x squared parabola, so that means it's going to be either pointing up or pointing down. I have a negative here, so my parabola is going to be pointing down. So my focus is going to be down from the vertex. It's going to be pointing that way. All right, so let's figure out the focus now. So that means 4p is equal to 12, so that's p is equal to 3. All right, so that means I'm going to go 3 down to get my focus. So this is vertex, this is focus. And we're going to go 3 up to get my directrix in. So we'll do them both. All right, so we can write our equation for the directrix and our ordered pair for the focus now. All right, so my focus is going to be 5, -1. And my directrix is going to be 1, 2, 3, 4, 5. Y is equal to 5. All right, so the last thing we need is the graph. So to get our width of the parabola in there properly, we'll use the length of the focal diameter. Okay, focal diameter, according to my equation, the length of the focal diameter is 12. So that means 6 on either side of my focus, because 1/2 of 12 is equal to 6. My focus is the midpoint of my focal diameter. All right, so let's do that. So 6, 1, 2, 3, 4, 5, so roughly here, and 1, 2, 3, 4, 5, roughly here. 6 on either side. All right, so let's go ahead and sketch that in. Okay, so I sketched it in there, and this is everything, so we're done with this problem. Okay, another kind of problem is when you're given several pieces of information and you're asked to find the equation and sketch the graph like this. Given the focus and the directrix, write the equation in standard form and sketch the graph. So first we want to put these two pieces of information on the graph to give us an idea of what the form of the equation should be. So if my focus is 10, 1, and my directrix, I'm just going to move my graph over a little bit, is x is equal to 4. Let's put those on the graph here. Okay, so I put those on the graph. Now, the distance between my focus and my directrix is 6. So 6 from here to here. All right, so if I cut that in half, right there, I'll be able to see where my vertex goes. So let's put the vertex in here. This is my vertex. All right, so this is 3, and this is 3. So that means the coordinates of my vertex, let's write those down, are x is equal to coordinates of the vertex, x is equal to 7, 1. So let's highlight that. So now the form of our equation, let's try to determine what that needs to be based on what we know so far. So we know it's pointing in the right direction, opening to the right, open to the positive direction, and that it's a y-squared parabola. So we can write down the standard form for the parabola for the equation. Okay, so we're looking to get it in this form here. So now that we know the vertex, we know what h and k are. So we can put those in, and we know what p is. P is 3. We can put that in as well. So we've got y minus 1 squared is equal to 4 times p, that would be 12, times x minus 7. Okay, there's our equation now. One more thing to do, let's get it on the graph. So we need to find the length of our diameter. All right, so the length of our focal diameter is the 12, so that means half of 12 is 6. So we need to go up 6 from my focus, so that'd be 1, 2, 3, 4, 5, 6. And then down 6, so it'd be 1, 2, 3, 4, 5, 6. And then we'll go ahead and sketch it in. All right, so there is my sketch. Okay, so we've answered everything that we needed to do here. So let's try one more problem. Okay, so in this problem it says you're given the focus and the vertex. So not the focus and the directrix like last time, but the focus and the vertex. Write the equation in standard form and sketch the graph. So here's our focus, here's our vertex. So let's put those two dots on the graph so we can figure out which way this is going. So I plotted those 2 points. There's the vertex and the focus. So since the focus has to lie inside the parabola, that tells you that it's going to be a facing up like this parabola, which is a y is equal to x squared parabola. This is an x squared parabola. So now we know what the form of the equation is going to look like, so let's write that down. Okay, so it's an x squared parabola, so that's the form of your equation. So now we already know h and k, of course, so h is here and k is here. So we can plug h and k in there. So that'd be x minus -3, so that's plus, opposite sign. Let's wait on 4p for just a second. Then we know y minus k, which is 2. So over in the graph here, this is 2 right here, so this is your p. So we know p is equal to 2. The distance between the vertex and the focus is p. All right, so of course we also know that p would be the difference between the distance between your directrix. Let's just sketch that in as well. This is your directrix, so that's right on the x-axis. Equation y is equal to 0. All right, so if p is 2, then 4p is 8, so we can put 8 right here. All right, so that's our equation. Let's get the 2 points at the ends of the focal diameter. So the length of the focal diameter is this number here, which is 8. So half of 8 is 4, of course. So through the focus and parallel to the directrix, I'll go out 4 in either direction. So that's 4, and that's 4. And then here's my vertex. So with those 3 points, I'm going to sketch it in. And there's my sketch. All right, so that takes care of our last problem. So you should have enough information now to approach your homework set. And if you run into any difficulties, let me know either via Remind or through email.